Let's now discuss another useful theorem, that is Fundamental Theorem of Arithmetic. But before we discuss Fundamental Theorem of Arithmetic, try to answer the following question. Now this is going to be fun. Okay, so here comes your question. Check if for any value of n, 3 power n is divisible by 6. So that's your question. Now we know that 3 power n can be written as 3 into 3 into 3 into 3 into etc. n times. And the question is, will this number be divisible by 6? If yes, what are those values of n in which this number becomes divisible by 6? If not, why not? Think about this question, take a piece of paper and write down your answer. We shall discuss the answer to this question shortly. Till then, let this question linger on in your mind, because what we are going to discuss next has a close connection with this question. In fact, any doubt that you had while solving this question will be clarified once you have a clear understanding of this theorem, that is Fundamental Theorem of Arithmetic. Before we discuss Fundamental Theorem of Arithmetic, let's quickly see if our basics are in place. Let's quickly revise what we have already learned in your previous grades. We have learned about prime numbers, composite numbers, etc. in our previous grades, right? So what do you mean by prime numbers? Prime numbers are numbers that are divisible by 1 and itself. Let me rephrase what I have said right now. Prime numbers are numbers that are only divisible by 1 and itself. And examples of prime numbers are 2, 3, 5, 7, 11, etc. And what are composite numbers? Simple. Composite numbers are non-prime numbers that are greater than 1. And examples of composite numbers would be 4, 6, 8, 9, 10, etc. But what about 1? Is it composite or is it prime? Recall that 1 is neither composite nor prime. Alright, now that your basics are in place, let's go on to discuss Fundamental Theorem of Arithmetic. Consider any number greater than 1. Let's say 230. Now we have learned in our previous grades that 230 can be written as product of its prime factors. So if you prime factorize 230, what are the prime factors that you are going to get? You can write 230 as 2 into 5 into 23. Notice that 2, 5 and 23 are prime numbers, and that is why we call them as prime factors. Now think about this. Is there any other way you can represent 230? Of course, I can change the order. I can write it as 2 into 23 into 5 or 23 into 5 into 2. But all of these expressions are one and the same, as it involves only the same prime factors. The question really is, can you express 230 as product of any other prime factors apart from 2, 5 and 23? Not really. Now consider any other number. Let's say 480. Now 480 can be broken down into 2 into 2 into 2 into 2 into 2 into 3 into 5. Think about the same question here as well. Can you express 480 as product of any other prime factors apart from these prime factors? If you think about this, you will again get the answer as no. Now what does it mean? It means that prime factorization of a composite number is always unique, and this is your Fundamental Theorem of Arithmetic. It's that simple, right? You think of any other composite number, larger or smaller, this is always true. So just like in science we say that atoms are building blocks of matter, we could say that prime numbers are building blocks of any composite number. This is why studying of prime numbers is crucial to the understanding of numbers. In the examples that we saw above, 230 is composed of prime numbers 2, 5 and 23. And the number 480 was built using prime numbers 2, 3 and 5. Right? So when you look at any composite numbers, you always think of it as composed of prime numbers. We can formally state fundamental theorem of arithmetic as follows. Every composite number can be expressed as product of its primes, and this factorization is unique. So that's fundamental theorem of arithmetic. So where do we use this fundamental theorem of arithmetic? Let's come back to the question that we discussed in the start of this video. Do keep your paper ready. We need to check whether you got the right answer. Alright, so what was the question? The question was to check for any value of n if 3 power n is divisible by 6. So what are we trying to do here? We are trying to divide 3 power n by 6. Now in order for this to be completely divisible, the denominator 6 should completely cancel off with the numerator. Then we can say that it's completely divisible, right? So the numerator here is 3 power n, which is 3 into 3 into 3 into 3 into etc. n times, and the denominator is 6, which is nothing but 2 into 3. Now observe closely the numerator and denominator. You can easily see that the 3 in the denominator will get cancelled off with one of the 3's in the numerator. But what about 2? Will this ever get cancelled off with the numerator? Not really. You take any value for n, what you are doing is you are just increasing the number of 3's in the numerator. But as long as you don't have a 2 in the numerator, the 2 in the denominator will remain as it is. What does it mean? It means that for any value of n, 3 power n will not be divisible by 6, right? We have just used fundamental theorem of arithmetic here. We prime factorized the numbers to get a deeper understanding of these numbers. Once we clearly saw that the prime factorization of numbers written in the numerator and denominator, we could easily see that these numbers will never be divisible. Alright, so did you get it right? If yes, great job. If not, don't worry. It's okay to make mistakes. It's through mistakes that we are going to learn and have a deeper understanding of all these concepts.